Okay, my Algebra 2 students, I'm going to go over the study guide. I have everything already solved, so I'm just going to kind of talk through it. Feel free to, if you understand a problem, just skip through it. And hopefully I've answered all the questions and let me know if I've made an error. So for problem number 1, there's a couple things you're supposed to find. So the vertex, the slopes, the domain, and the range, and then state if you have a minimum or a maximum. So for this problem, first of all, the vertex is 0, -4. Remember that it is the number being added or subtracted to x within the absolute values, the opposite, comma, the number that was being added or subtracted at the end. The slope is positive or -3. The slope is always the number that's in front of our absolute values. For the domain, it is all real numbers. You can plug in any number for x for this equation and take its absolute value, multiply it by -3, and subtract 4. However, the y's are not the same thing. The y's are less than or equal to -4. And if you look at your graph, because this is your graph, the highest the y's go is -4, and then it goes below that, which is why the range is the set of y's such that y is less than or equal to -4. And that problem has a maximum. The vertex is actually the maximum of that absolute value equation. For problem number 2, the vertex is -3, which is the opposite of that, comma -1, which also happens to be the minimum of that graph. Since there's no number in front of the absolute values, it's a 1, so your slope is positive or -1. So I went from my vertex, I went up 1, right 1, and then up 1, left 1 to get my two sides. My domain is all real numbers. And my range is y is greater than or equal to -1. So the lowest that the y value goes is -1, and it's everything above. And again, our vertex is the minimum on this one. For problem number 2, the vertex is +1, because it's the opposite of 1, comma 0. There's no number being added there, therefore it's a 0. The slope is the positive and negative 2/3, the number that's in front of our absolute values. Domain is all real numbers, and the range is y is greater than or equal to 0. So 0 is the very bottom of our y's, and it's everything above, and that is a minimum. For problem number 4, when you write your equation, you first have to include your vertex, which your vertex on this one is right here, is at 4, -2, and that's where I got this -4 and this, comma, +2, that +2. And then I had to make a slope triangle to figure out what the slope was. So I used those 2 points, and it was up 1/4, so it means a slope of 1/4. And it's opening up, so it's a positive 1/4. For number 5, the vertex is at 3, 3, and that's where the opposite of 3, 3 came in. And I also did another slope triangle, and from my vertex to one of my nice points, I found that it was down 3/1, and since it does open down, it's a -3 for the slope. Number 6, the vertex is at -4, -1, which is where these numbers came from, the opposite of 4, -1. And I made a slope triangle, which was up 3/1, so it has a slope of 3. And since it opens up, it is a positive slope. Okay, number 7 is asking for the transformation. This is very similar to those problems that we had the t-tables on the back, and then we made colorful graphs on the front and explained how it moved. So the +1 means it moved to the left 1. The -8 means it moved down 8. And since this is greater than 1, it means it's steeper than the parent function, because the parent function just has a slope of 1. Okay, so for problems numbers 8, 9, 10, and 11, there are multiple ways to solve this. I'm just showing you one of the ways. So if it was factorable, I factored it. If I could solve it by square rooting, I did, and if not, quadratic formula. So for problem number 8, it was actually factorable. The two numbers that multiply to -8 and add to 7 are 8 and -1. So you have x plus 8 times x minus 1. If you have two things that multiply to 0, one of them has to be a 0. So that's where you get your two equations. Either the x plus 8 is the 0 or the x minus 1 is the 0. So you end up with -8 and 1. Okay, for problem number 9, I ended up using the quadratic formula because I couldn't factor it. if you use negative b plus or minus the square root of b squared minus 4ac all over 2a, you end up with 1 plus or minus the square root of 141 over 10. The square root of 141 can't be reduced, so that is your final answer. You could come across, you could make a decimal equivalent of it. I didn't do it. Number 10. So for this one, if you square root both sides, the square root of 49 is 7. But remember, when you're solving an equation and you take a square root, it's the plus or minus version of it. Then if you subtract 2, you end up with 5 and negative 9. And the way I did that is if I did positive 7 minus 2, I get 5. But negative 7 minus 2, I get negative 9. So that's how I came up with my two answers. And number 11 was, first I had to add 1 to both sides because my equation didn't say equals 0, so I need to make it say equals 0. Then I plugged it into the quadratic formula, negative b plus or minus the square root of b squared minus 4ac all over 2a. And I ended up with this square root of 12, which could actually be reduced. So 12 is 4 times 3, and the square root of 4 is 2. So I end up with a negative 4 plus or minus the square root of 2 root 3 over 2. And if you divide both of those by 2, you get negative 2 plus or minus the square root of 3, which again you could make as a decimal. Go for it. Number 12. First of all, that's my graph for number 12. I just kind of used the points that I found and chose a couple other ones to get a nice curve. So for the axis of symmetry, remember, is negative b over 2a. So that was negative 4 over 2 times negative 1. So the axis of symmetry was 2. Using the axis of symmetry, if you plug it into your equation, you end up finding that y equals 8, which, putting it together, your axis of symmetry with that y value gives you the vertex. And if you looked at my graph, since it opens down, you know it opens down because the coefficient of x squared is negative. That ends up being the maximum. For the y-intercepts, I made y 0, so then I had 0 equals negative x squared plus 4x plus 4. I plugged that into the quadratic formula. Partway through, I got to the square root of 32. Well, 32 is 16 times 2, and the square root of 16 is 4, and you still have a root 2, which is where this part came from. But then if you reduce both of these, you end up with 2 plus or minus 2 root 2. The negative in front of that original 4 went away because it was a negative divided by negative. For the y-intercepts, x equals 0. So don't forget that on the x-intercepts, y equals 0, and on the y-intercepts, x equals 0. The other letter is always 0. So if you plug in 0 to all of your x values, you end up finding that y equals 4, so your y-intercept is 4. The domain for this parabola is all real numbers, and the range is that y is less than or equal to 8, because if you look at your graph, the highest y is at 8, and it goes down from there. For problem number 13, the axis of symmetry is 2. The axis of symmetry, remember, is the x coordinate of the vertex, and this problem is in vertex form. So the vertex is also at 2, negative 3. So if you did your foiling and simplifying, you could do negative b over 2a, but if you recognize it's in vertex form, it's a little less work. For the x-intercepts, I've made y equals 0, and then I ended up just solving it, first of all, to get the squared by itself by adding 3 to both sides. And then to undo a square, I square rooted both sides. Remember, it's the plus or minus version. So adding 2 to get x by itself, so these are gone. X equals 2 plus or minus the square root of 3. And for the y-intercept, x equals 0, so I plugged in x was 0, and I solved it, and I got a 1, so the y-intercept is 0, 1. For the x-intercepts, by the way, you could find that as a decimal. I didn't. For the domain, it is all real numbers, and for the range, y is greater than or equal to negative 3. Since the vertex is the minimum, y is at negative 3 and above. For number 14, first of all, I did distribute or FOIL the x minus 7 times x plus 1 and distributed the negative 1/2, getting this equation up here so that I had a, b, and c. And then using a, b, and c, I found the axis of symmetry was at x equals 3. And then plugging in this 3 into where x is, I found out that the vertex was at 3, 8, because I got an 8, which since the coefficient of x squared is a negative, that ends up being a maximum because our parabola opens down. And for the x-intercepts, I made y equals 0, and it was prefactored, which was really nice. So either x minus 7 equals 0 or y plus 1 equals 0, so you end up with x equals 7 or negative 1. And at the y-intercept, I plugged in x equals 0, and I calculated it and got 7 halves. For our domain, it's all real numbers. And for our range, y is less than or equal to 8, because again, on our parabola, this is the maximum, and so y goes up to 8, and it's below that. Okay, number 15. So this was just solving any way that you possibly can. If you factored and you found another way to solve it, it works too. So for the way I solved this one is I first added 16 to both sides because the only x term was the x squared, so I'm working on getting the x squared by itself. So I added 16 to both sides, and then I divided both sides by 9, and I got x squared equals 16 ninths. And then to undo a square, I square rooted both sides, and the square root of 16 is 4. The square root of 9 is 3, so it is plus or minus 4 thirds. For number 16, there's no c, it's only ax squared plus bx, so I factored out a GCF, and the GCF was 5x. So I have 5x times 5x minus 3 equals 0. Well, those are the two things that have to multiply to equal 0. So either the 5x is 0 or the 5x minus 3 equals 0. And if you solve those both for x, you get x equals 0 or negative 3/5. Number 17, I could have factored it if I and found like a GCF, but it wouldn't go nearly as far as I wanted it to, so I decided to solve for my x squared. So I subtracted 8 from both sides, and then I divided both sides by 4 to get x squared by itself, and I got x squared equals negative 2. So right there, I know I'm going to have an imaginary number, because once I square root it, I end up with a square root of a negative. So remember that negative 2 is negative 1 times 2. So if you separated those, you'd have the square root of negative 1 times the square root of 2, and it's plus or minus because you're square rooting to find x. And the square root of negative 1 is our I, and we still have the square root of 2, and it's a plus or minus. Number 18, this does have all three terms, so I needed to get them all on the same side, so I first subtracted 3 to get it to equal 0. And I couldn't come up with anything that multiplied to negative 15 while adding to 1, so I decided I had to do the quadratic formula. So when I plugged it into the quadratic formula, I got negative 1 plus or minus the square root of 61 over 10. And again, you could make that a decimal if you wanted to, and 61 I couldn't simplify. Number 19, again, doesn't equal 0, so I first subtracted x from both sides to make it equal 0. And then I decided to see if I could factor this. So a times c is negative 6, and the coefficient of x, b, is negative 1, and that does actually work. So the two numbers that multiply to negative 6 and add to negative 1 are negative 3 and 2. So if I put it into my box and factor out the GCF of the rows and columns, I end up with this right here. I have x plus 1 times 2x minus 3 equals 0. So if I have two things that multiply to 0, one of them has got to be a 0. Solve them both for x. Our answers are negative 1 and 3 halves. Number 20, again, it didn't say equals 0, so I added 15 to both sides. This one is also factorable. The two numbers that multiply to 15 and add to negative 8 are negative 5 and 3. So I have x minus 3 times x minus 5 equals 0, so x equals 3 or 5. Number 21, I could not find any two numbers that multiply to 22 and add to negative 6, and rightfully so, because I had to use the quadratic formula. So plugging it in, I ended up at one point in time with a negative 52. Oh, I think I forgot my I. So I should have an I out here. There should be an I right there. So 52 is 4 times 13, so I can actually simplify the square root of the 52. So that's where my 2 came from. The square root of 4 is the 2, and the leftover 13 goes there, and with my I, because it was a negative 52. And if you reduce both of these by 2, you get 3 plus or minus I root 13. Number 22, very similar to the difference, how the absolute values was transformed. The negative 2 means it was moved to the right 2. Remember, it's the opposite. 5 means it was moved up 5. And this 4 means that it is steeper than the parent function because the parent function only has a 1 in front of the x squared. Okay, number 23. So I always had to write this equation just so I could visually see where I was plugging everything in. So for 2, 0, that went here and here. And for 0, 4, they went here and here. If you simplify and solve for a, you get a equals 1. And then for your final answer, you only keep your vertex parts. You just put x and y back, and then a is 1. So it is y equals x minus 2 squared. Same thing with problem number 24. So your vertex was 0, 0, which is where those 2 came from. Your other point was 1, negative 2, which is where those 2 came from. And if you solve, you ended up with a equals negative 2. And since all of the x and h and k are 0, you end up with just negative 2x squared. Number 25, the vertex was negative 3, negative 2, which is where those 2 came from. And the other point was negative 2, 4, which is where those 2 came from. If you simplify, you end up with a equals 6. So only plugging in the vertex, leaving x and y alone, y equals 6, parentheses, x plus 3 squared, minus 2. And number 26, the vertex is 1, 2, which is where those came from. And the other point is 2, 1, which is where those 2 came from. If you solve for a equals negative 1. And our equation, putting back x and y as x and y, is y equals negative 1, parentheses, x minus 1 squared, plus 2. Okay, number 27. So the key to this one is that the starting height is 0, which means h sub 0 is 0. And the velocity was 80, which means that v is 80. So our equation, when we plug in what we know, is h of t equals negative 16t squared plus 80t. Using that, if your ball lands back on the ground, it means that the height is 0. So I made it equal to 0, and I solved, and you could take out a GCF on this one because there is no constant, so it's nice. We don't have to use the quadratic formula or factor it. So if you factor out a 16t, you end up with t equals 0 or 5. Well, the 0 is when it started, so that means that after 5 seconds is when it landed back on the ground. What is the highest distance achieved by the ball? So that's going to be your vertex. So the first thing you have to do is find your axis of symmetry, which is your negative b over 2a. So using that, you end up with 2.5. And if you plug in 2.5 to your equation, so substituting 2.5 for t, you end up with 160 feet. So its highest vertical distance is 160 feet. Number 28, write each in vertex form by completing the square. So first you take your coefficient of x squared is a 1, so that's good. We don't have an extra step. The coefficient of b, you divide it by 2, and then you square it. And what you do is you not only add it to the first 2 terms, but you subtract it from that constant. And that will get you your factored equation, because these first 3 are a trinomial square, which happens to be x plus 4 squared, and 3 minus 16 is negative 13. So if I'd asked you what's the vertex, you could tell me negative 4, negative 13 is my vertex. For number 29, the coefficient of x squared is not a 1, so that's why we had to divide everything by 2 first, so that we would have x squared be by itself. So it's kind of like we're going to store the 2 underneath the y right now. So just don't worry about the fact that this is y squared. The coefficient of x is a 4. We divide it by 2 and we square it and we end up with 4, which is why we added and subtracted 4 from both spots, because if you add it and subtract it, it's like you've done nothing, so you haven't changed your equation, even though you've made it so that you can actually do something. So these first 3 terms are x plus 2 squared. Negative 3 halves minus 4 is negative 5 halves. But to finish your equation, you can't have a y over 2, so that's why in the orange I multiplied everything by 2 to get y by itself, and you end up with y equals 2, parentheses, x plus 2 squared minus 5. And number 30, coefficient of x squared is a 1, which is nice. Our b is a negative 4, so negative 4 over 2 squared is 4, so we added 4 and subtracted 4. The first 3 terms get you an x minus 2 squared. Negative 4 minus 4 is negative 8. So again, our vertex is 2 comma negative 8 if I'd asked you, because now you have it in vertex form. And number 31, the coefficient of x squared is not a 1, it was a negative 1. So we first had to divide everything by negative 1. But if you look at problem number 30, we've already done that problem. The only difference is that we now have a negative y. So if you want to make the y positive, you just multiply everything by negative 1, and you change the sign of everything, and now you have negative, parentheses, x minus 2 squared plus 8. And our vertex would be 2 comma 8. Okay, solving and graphing. Less than is an and problem. So if you separate this, you take the inside of the absolute values, and first you leave it alone, is less than or equal to 27, and now you switch the inequality and make it a negative answer. If you solve those two, you end up with x is less than or equal to 9 and x is greater than or equal to negative 4.5, and always goes in the middle because it has to be where they overlap. It has to be true for both, and those are solid dots above 9 and above negative 4.5. Number 33, first our absolute value is not by itself. You have to first make it by itself by subtracting 10 from both sides. And you get x is minus 8, absolute valued, is greater than 12. Greater is an OR problem. So leaving everything alone, we have x minus 8 is greater than 12. Or if you switch the inequality and make your 12 negative, you have your second inequality. So x minus 8 is less than negative 12. Solving those two, you get x is greater than 20 or x is less than negative 4. Since it's an OR, they do not have to be going in the same direction. They usually are going in the opposite directions because it only has to be true for one or the other. So this one is an open dot at 20 going to the right and open dot at negative 4 going to the left. Number 34, absolute value is not by itself, so we had to subtract 8 from both sides first. Absolute value of 4x minus 7 is greater than or equal to 9. So if you separate them first, and it is greater, so it's an OR problem. The first one stays the same. The second one, you flip your inequality and you change the sign to be a negative. And if you solve that, you get x is greater than or equal to 4 and x is less than or equal to negative 1/2. So since this is an OR, they usually are going in the opposite direction. Solid at 4 to the right, solid at negative 1/2 to the left. And number 34. You have a denominator underneath your absolute value, so you have to multiply both sides by 7 just to get your absolute value by itself. It's a less than, so it is an and problem. If you separate it where the first one stays exactly the same, 3 plus x is less than or equal to 35, and then on the other one, switch it and make it negative, and solve it, you get x is less than or equal to 32, and x is greater than or equal to 38. So since it's an and, it's where it overlaps, so it's in the middle. Okay, last thing, remember that I will offer you guys some extra bonus points if you can derive the quadratic equation. I'm going to show you again. I'm just going to make one little tweak because it might make more sense to you, but it's exactly the same stuff, and I'll show you where my slight changes. So we first have to start off with ax squared plus bx plus c, all variables, no numbers. First, we need to make sure x squared is by itself, so we divide everything by a. And then we have 0 equals x squared plus b over ax plus c over a. Now this is my slight change. So if you prefer, you can move your constant to the other side immediately so that you do not have to worry about it. So subtracting CA from both sides gets you CA equals x squared plus b over ax. Then we're going to take the coefficient of x squared, we're going to divide it by 2, and we're going to square it, which gets us b squared over 4a squared. So what you do with that is you add it to both sides. So if our previous one, we just added and subtracted it from the same side because we hadn't moved over our c over a. So it just depends on your preference. With this is a trinomial square right here because that's the way we created it. And on this side over here, it's a fraction. We need common denominators. So the denominators right now are an a and a 4a squared. If I multiplied this one by 4 in the numerator and denominator, I'm almost there. I just need one more a, so I'm going to put an a here and here, so I'm going to square it. And that's where the b squared minus 4ac comes from, and my common denominator is 4a squared. And it is x plus b over 2a squared. Then, if you square root both sides so that you can cancel your squares, you end up with the plus or minus, because it's plus or minus, the square root of b squared over 4ac all over 2a, because the square root of 2a squared, 4a squared is 2a. And the last step is to get x by itself by subtracting b over 2a. But what's nice is they already gave you common denominators. So the numerator is a negative b and a plus the square root of b squared minus 4ac, and our common denominator of 2a is already there, and there's the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Feel free to come see me tomorrow during lunch, after school, and be ready for our test on Friday. Good luck, guys.